So leave insert differentiation tutorial higher level. So the chain rule. We'll take a very simple example just to demonstrate the rule. Y is equal to 3x plus 2 all to the power of 4. Now, the chain rule enables us to differentiate without having to work or multiply 3x plus 2 by itself 4 times. Okay? So what we do is dy dx equals, we multiply the power by whatever's in front of our bracket, which is 1 in this case. So 4 by 3x plus 2. We take 1 from our power and we multiply by, multiply by the differential of what's inside the bracket, which is the differential of 3x plus 2, which is 3. So dy dx, the answer is 12 into 3x plus 2 all to the power of 3, and you cannot multiply the 12 in to the bracket because it's raised to the power of 3. You'd have to work that out first, which would be a waste of time. So the second example is if you had something like the square root of 4x plus 2. Okay, so how we differentiate this is we use our surds, or we convert our surds into indices. So that's 4x plus 2 all to the power of a half. So to differentiate, dy dx is equal to a half by 1, which is a half, multiplied in the front of the bracket, by 4x plus 2 all to the power of a half minus 1 by the differential of what's inside the bracket, which is 4. So we multiply our half by 4 and we get 2, and it's 4x plus 2 to the power of minus a half. So to simplify it, dy dx is equal to 2 all over 4x plus 2 all to the power of 1 half. Now to bring it back into third form, dy dx is equal to 2 all over the square root of 4x plus 2. Now another example on use of the chain rule would be if you had an example like y equal to x squared, the square root of 2x plus 1. Okay, so we have x squared multiplied by the square root of 2x plus 1. So in this case it's a product rule and it's a chain rule mixed into the middle of it. So we'll just get rid of the surd. So it's 2x plus 1 to the power of a half. U is equal to x squared, v is equal to 2x plus 1 all to the power of a half. Du dx is equal to 2x, dv dx, we've got to use the chain rule to differentiate. So it's a half by 2x plus 1 to the power of minus a half multiplied by 2. So dv dx is a half by 2, which is 1. So it's 2x plus 1 to the power of minus a half. So dv dx is 1 all over 2x plus 1 to the power of a half, which we bring back our surd into play, which is 1 all over the square root of 2x plus 1. Now, so dy dx, then the full dy dx, we were using the product rule. So it's u times dv dx, which is 1 all over the square root of 2x plus 1, plus v times, which is the square root of 2x plus 1, by du dx, which is 2x. So dy dx is x squared all over the square root of 2x plus 1 plus 2x, the square root of 2x plus 1.